Here we have two vectors d1 and d2, two displacement vectors. d1 is equal to 6 and d2 is equal to 3. So we have two displacement vectors, d1 equal to 6 units along positive x and d2 is equal to 3 units along positive x, both point in the same direction. What is the resultant vector? What is the net effect of these two vectors acting in the same direction? Positive x and negative y directions are as shown. A vector has horizontal and vertical components. These components can be positive, 0, or negative. A vector has magnitude and direction. We know that. All right, so let's solve our vectors into x and y components. What is d1? It is 6 units. So magnitude is 6. What is the direction? Positive x. So what is the interpretation? We have d1 completely along the horizontal. So it is horizontally to the right, positive x, horizontally to the right. Now let us take the next vector, d2, and what is the x component of that vector? It is 3 units. And what is the direction? Again along positive x, horizontally to the right. Let's go back to d1. It is a horizontal vector. So what can we say about the y component? Is 0. What about the y component of the horizontal vector d2? 0. So what is the interpretation? When a vector is horizontal, it has 0 vertical component. When a vector is horizontal, it has 0 vertical component. Since both our vectors are in the positive x direction, all we have to do is add. So what is the net result of 6? What is the net result of 6 and 3? So we have dx equals 6 plus 3 and that is equal to 9. How about dy? 0 plus 0 and that is equal to 0. So dx is equal to 9 and what is dy? And that is equal to 0. So what is the resultant? The magnitude is given by square root of dx squared plus dy squared. What is dx? 3 plus 6 or 6 plus 3, it is 9. And what is dy? 0. Substitute that and what do we get? The magnitude of the resultant vector is equal to 9. What about the angle? Angle theta is tan inverse dy over dx. Since dy is equal to 0, you have tan inverse 0 and that is 0. So we can put all these into a table. So we take the vector d1, resolve into x component and y components. Take the vector d2, resolve it into x component and y component. Insert the direction, positive 6 and positive 3. And then the resultant vector of d1 and d2 will then be easy to find. Add the x column, get dx. Add the y column, get dy. And then the resultant is given by square root of dx squared plus dy squared. Many textbooks use resultant or. It doesn't matter. It's really up to you as long as you understand. Once you have the horizontal sum and the vertical sum, you know the horizontal and vertical components of the resultant vector. From that you can find the angle and all that. And this is George Mathew signing off. Good luck.